Hello everyone, today we're going to be solving LeetCode 671, second minimum node in a binary tree. So the question description is, given a non-empty special binary tree consisting of nodes with non-negative values, where each node in the tree has exactly 0 or 2 subnodes. If the node has 2 subnodes, then the node's value is the smaller among the 2 subnodes. More formally, the property of node.val or root.val is the minimum between root.left.val and root.right.val always holds. Given such a binary tree, you need to output the second minimum value in a set of all nodes values in the whole tree. If there's no such second minimum value, output -1 instead. All right, that question was extremely wordy, but what it's basically saying is that every node in this special binary tree will either have 0 or 2 children. And if it has 2 children, the node's value is just going to be the minimum between the left and right subtree. So as you see here, when we're at 2, we look to the left, there's a 2, right, there's a 5, and so min of 2 and 5 is 2, so this value is going to be a 2. Same here with 5. The min of 5 and 7 is 5, so this is going to be 5. So here I drew out the question here, and the answer should be 5. So let's say, since the question is asking what's the second minimum value of all the values in the tree, let's say we went through and we added all the values into an array, something like this: 2, 2, 5, 5, and 7. Here, the answer is 5, because we want the second minimum. So as you can see, that makes sense. And let me give you a counter example. So let's say we had this tree here, 2, 2, and 2, 2. We would add all the nodes to an array. Let's say we had 2, 2, and 2. We want to return the second minimum. We can't return 2 because 2 is the first lowest and the second lowest. Actually, there's no second lowest because there's only one value here. So we should return -1. But our array has 3 values. So how can we remedy this issue? And I'm going to tell you, instead of appending to an array, what we can do is append to a set, because a set can't have duplicates, so it will only have unique values, and we would just have to return the second number in sorted order. And if there's less than if there is one number or less, then we should just return -1. So let me show that here. Instead of an array, what we're going to do is add to a set. So let's pretend let's say this is a set. We'd add 2, and since sets can't have duplicates, we go to the left and we'd say 2, and there would not be another one. And at the end, we just have 2. Now we say if our set only has one value, then we should return false, or -1, because there is no second minimum because there's only one option. And the same thing here. Let's go through here and pretend we're adding to a set. So let's say this is our set, and we go through and we add every number. We add the 2. We go to the left, we see a 2. That's already in there, so we won't add that. We'll go to the right, we'll see a 5. 5 is a unique number, so we'll add that. We'll go to the left of 5 here to this 5. We'll see that that's a 5, but we already have a 5, so we can't add that. We go to the right and we'd add 7. So our set consists of 3 numbers, 2, 5, and 7. The answer is 5 because it's the second value here. But unfortunately, sets don't have indices, so what we're going to have to do is convert this set to an array. So we could that's easy, just wrap it in a list operator or in a list data structure. So the list will essentially be a list of unique values, and all we have to do is return the value in the first index, because it's 0, 1, and 2. The first index always holds the second value, and we'd return that number. And there's one caveat: since this isn't a binary search tree, we want to make sure we sort this list before we return the first index, because it might not always turn out to be sorted like this. All right, so let's actually get into the code. How would we solve this? So as you remember in the beginning, we want to have a set. Let's just call it set equals set. Next, we want to create our depth first search function. So depth DFS. It's going to take in a node. What we're going to do now is have the base case, since this is a recursive function. And every time we hit a not node, let's say we're at 2 and we went down to this null node and this null, we want to just return because we can't add anything there. So we're going to say if not node return. Next, what we want to do is say node or set dot add node dot val. So that's essentially adding our first number. So in this case, we'd be adding the 2, and then what we want to do is go left to this left subtree. So to do that, we're going to say DFS node dot left. That's going to go to the left subtree here too. It's going to add this to our set. It's already in there, so the set won't change. And next, since we're in the second recursive call, we're going to try to go left and right. But they will hit our base case here and we'll return back up. Now, since we've explored the whole left subtree, we want to explore the right subtree. So we're going to say DFS node dot right So if we go node.right, we'd add 5 to our set. New call, so we go left, add 5. 5's already in there, so we won't do that, and add 7. And at the end, our set should have 2, 5, and 7. Now what we want to do is convert our set here to a list. So we're going to call it array. Array equals set inside of a list. So we're going to say list set. So now this is now an array inside of a set, instead of a set with unique values. Next, what we want to do is sort to make sure the second value that we pick is always going to be the second minimum, because we're sorting in ascending order. So array.sort, and now return array at the first index, and that's the first one. But as you remember, there is a case when we return -1. That's if the set doesn't even have enough values to equal to even get a second minimum value, like in this case here where there's only one value. So if we're looking at unique values, all we have to do is say if the length of array equals 1, which means there's only one unique value, we just have to return -1. And this should be good. All we have to do is make sure we actually call our function, because our set will be empty if we never called it. So we're going to say DFS root, and we should be fine. Let's run this, double check everything. I think it looks good. Let's try it out. And there we go. We solved the problem. Hopefully this was clear and concise. And if you have any questions, comment down below. Peace.